Solaris topics. Race condition in Solaris. Definition: a situation where two or more processes or threads access shared resources like files, memory without proper synchronization, causing inconsistent results. Example: two processes updating the same configuration file without file logs. Prevention: use mutexes, semaphores, force, or Solaris thread libraries. In shell scripting, use file logs, flock, before writing operations. For cluster environments, configure fencing mechanisms. Split brain in Solaris. Definition: in a Solaris cluster, when cluster nodes lose communication with each other and assume the other node is down, both attempt to take ownership of shared resources. Impact: data corruption due to concurrent write access. Prevention: use quorum devices, disk quorum or quorum server. Ensure proper heartbeat configuration between cluster nodes. Configure fencing to block access from a misbehaving node. WWN ID LUNs. WWN ID worldwide name, unique identifier assigned to each storage port or device in SAN. How to find in Solaris: lux ADM-E port or CFG ADM-AL. Purpose: used to map host HBAs to storage arrays and allocate LUNs. How to scan newly given LUN in Solaris: identify HBA ports, lux ADM-E port or rescan devfs ADM-C disk. Check if disk is visible. Format: if still missing, check SAN connectivity using CFG ADM. Format commands in Solaris. Purpose: list disks, creates partitions, labels disks. Importance in LUN scanning: format confirms whether the OS detects the new LUN. VXVM in Solaris. VX disk setup. Purpose: prepares a new disk for use with Veritas Volume Manager. Scan for new disk. VX disk space list. Initialize. VX disk setup -I disk name. Create disk group. VXDG init. DG name, disk name. ZFS resizing file system in Solaris 11. Increase ZFS set quota is equal to plus size, pool name or FS name. Or simply ZFS set quota is equal to 500G my pool / data. Decrease reduce quota, ensure data usage less than new size, auto grow. ZFS will grow automatically if quota is unlimited. Linux RHL 9.5 topics. Bonding in network configuration. Install necessary package. Install -y network scripts. Create bonding config /etc/sysconfig /network-script /ifcfj-bond 0. Device is equal to bond 0. Type is equal to bond. Bonding underscore master is equal to yes. Boot proto is equal to static. IP-ATTR is equal to 192.168.1.10. Netmask is equal to 255.255.255.0. Gateway is equal to 192.168.1.1. Bonding underscore OPTS is equal to double quote mode is equal to active-backup MII-MON is equal to 100. Configure slave interfaces. IFCFJ-ENS33, IFCFJ-ENS34. Device is equal to ENS33. Master is equal to bond 0. Slave is equal to yes. Boot proto is equal to none. Restart network. Similarly for ENS34, change the device name to ENS34. Master is equal to bond 0. slave is equal to yes, boot port is equal to and restart network, nmcli connection, reload, change secondary to primary after primary NIC failure. If active backup mode bonding automatically switches to secondary NIC. To manually change echo plus ENS34, redirect it to /sys/class/net/bonding/bond0/bonding/active_slave. Booting Linux RHL 9.5 BIOS or UEFI post. Bootloader grub2 loads kernel or initramfs. Kernel initialization. Systemd runs init services. Login prompt. File system resizing in Linux LVM. LV extend -capital L plus 10G /save/VG name/LV name. Resize to fs/save/VG name/LV name. XFS underscore grow fs/mount point. Reduce XFS not supported backup. Unmount MKFS with smaller size. Restore data. XFS steps to reduce file system. XFS cannot directly string directly backup data. Unmount FS. Recreate FS with smaller size. Restore backup. Coordination with Red Hat team. The SOS report. Generate SOS report. Share the tar.gz file with Red Hat support for troubleshooting. Generate sysadmin topics. How to request lunch from storage team. Information to include in form or email. Server host name and operating system. WWN IDs of HPAs. Required lunch size and type. SSD or SAS. SSD or SAS. Purpose DB, logs, backup, multipath requirement, file system type. Patching step by step. Check backup or snapshot availability. Notify stakeholders. Check disk space. Update repositories. Apply patches. Yum update -y. Reboot if kernel updated. Validate services. History of CPU usage for a time period. SAR -u-f/var/log/sa/sa05. Log messages location. General log /var/log/messages. Secure log /var/log/secure. Boot log /var/log/boot.log. Kernel panic mode resolution. Check logs /var/log/messages console output. Boot in single user mode. Rebuild initramfs if corrupted. Dracut-force. Repair FS if needed. fsck-y/stave/mapper/root. BIOS post hard disk failure. Check cables and BIOS setting. Replace disk if faulty. Restore from backup. Kickstart file configuration. Auto install config file for RHEL. Example install lang en_us keyboard us network -boot proto is equal to DHCP root PW Red Hat time zone UTC clear part -all -init label auto part reboot. After kickstart some service failed. Check /root/anaconda-ks.cfg for misconfiguration. Verify service logs. Enable and restart. Systemctl enable -now. Service name. Terraform provisioning of hardware. Define resources in .tf files. Example resource and Azure rm_linux_virtual_machine in example in braces name is equal to my VM close braces run terraform init terraform plan terraform apply Ansible configuration creates host inventory, write playbook site.yml, Ansible-playbook-i host site.yml. First, don't panic, assess the situation, confirm symptoms, kernel panic, does the server power on BIOS or post check, do you get a grub menu or kernel panic, any file system errors or missing disks, identify whether patching replaced the kernel or broke our configuration files, boot into rescue or recovery mode. Most Linux distros allow you to recover from installation media. Insert the OS installation DVD or ISO or mount via IL or ID rack. Boot from the media and choose Rescue a System, RHL or CentOS or Alma or Rocky. Mount the root file system chroot/mnt/simage. Check boot logs. journalctl-xb dmesc pipeless. Rollback kernel if patch broke. Patching often updates the kernel. If the new kernel is broken from grub menu, press E on the kernel entry. Boot an older kernel. Select from advanced options. Once booted, rpm-qa pipe grep kernel RHL based. Sudo dnf remove kernel-bad-version or set grub to boot the old kernel permanently. grub2-set-default 0 grub2-mkconfig-o/boot/grub2/grub.cfg. Restore critical config files. If patching overwrote configs, restore from backup rsnapshot, bakula, netbackup, etc. rsync-av/backup/etc/etc. If no backup, use /etc/backup or .rpm save or .rpm new files created by package managers. File system repair. If you see fsck errors, you mount /dev/htxy fsck-fy/dev/htxy. Replace htxy with your root partition. Restore from system image backup. If server is fully dead after patch, restore bare metal image from bare metal backup solutions. Clonezilla, Acronis, Veritas, NetBackup, PMR, IBM TSM, RARE, relax and recover. Boot recovery media, select restore, choose backup date. This will override the system to a pre-patch state. Reinstall bootloader if grub damaged. If grub is corrupted, mount /dev/htxy on /mnt, mount --bind/dev on /mnt/dev, mount --bind/proc on /mnt/proc, mount --bind/sys on /mnt/sys, chroot/mnt, grub2-install /dev/htx, grub2-mk-config-o/boot/grub2/grub.cfg, exit, then reboot. Post recovery hardening, validate all services, systemctl-failed. Disable problematic patches, dnf version lock, add pkg. Document the failure for the future patching windows. Best practices to avoid future downtime. Always take a full OS image before patching. RARE, MK, Rescue, Clonezilla, etc. Maintain kernel rollback option in grub. Test patches on a staging server first. Keep bootloader rescue media handy. Note, here is a SAR systat setup and usage RHL 9.5. What it does: SAR collects and reports historical system activity, CPU, memory, IO, network queues. It is provided by the systat package. Red Hat customer portal. Install sudo dnf install -y systat. Install SAR, SADC, SADF, SA1, SA2, etc. Enable data collection systemd timers plus service. Enable and start the systat service and its timers so samples are written periodically. Sudo systemctl enable -now systat, systat-collect.timer, systat-summary.timer. Or if already installed, sudo systemctl start systat systat-collect.timer systat-summary.timer. On RHL or CentOS, modern installs systat uses systemd timers. Default sample interval is equal to 10 minutes. Verify collection files. Daily binary files are typically in /var/log/sa named sadd. dd is equal to day of month. ls-l/var/log/sa. Example /var/log/sa/sa08. Data collected on the 8th. If you see SA asterisk files, collection is working. Ad hoc real-time sampling, no setup needed. You can gather live samples immediately. Every sample every 2 seconds, 5 minutes. SAR 25. CPU only in human form. SAR-U13. Formats are interval-second count. The command will show live snapshot, does not require /var/log/sa. Read historical data from var log sa /var/log/sa. Show CPU report from the /var/log/sa file for today. Example sudo sar-f/var/log/sa/sa dollar in parenthesis date plus %d-u. Common switches, use them with -f for live sampling. -u CPU, percentage user, percentage system, percentage IO wait, percentage idle, capital P all, per CPU stats, -r memory, KB mem free, KB mem used, percentage mem used, -d block device input or output per device, -b input or output and transfer counts, TPS, KB per read per second, KB or per underscore read kilobytes or underscore read per second, etc. -n they have network device stats, RX or TX, -q run queue and load averages. Export and convert reports. Use SADF to convert binary SA files to CSV, JSON and other formats. CSV for CPU report as sudo sadf-d var log/var/log/sa/sa dollar parenthesis date plus %d -u sar-cpu.csv JSON sudo sadf-j /var/log/sa/sa dollar parenthesis date plus %d -u sar-cpu.json. SADF is the formatter for SAR data. Change collection interval if you need more granularity. Default timer collects every 10 minutes. Use a timer over time rather than editing the shipped unit. Sudo systemctl edit -full systat-collect.timer. Change on calendar. Example *:00/1 for every minute. Sudo systemctl daemon-reload. Sudo systemctl restart systat-collect.timer. Red Hat docs note how to change the default 10-minute interval on RHEL 8 or 9. Adjust carefully. Shorter intervals use more disk or CPU. Quick interpretation cheats. High percentage IO wait plus low percentage idle. Processes waiting on disk. Investigate SAR-d or IO stat. High percentage system. Kernel IO or IO activity or interrupts. Per CPU imbalance. Check SAR-p capital P all or hot CPU spinning or IRQ affinity. Network splices SAR-n dev. Use these together with top IO top PID stat for process level correlation. DMS kernel ring buffer viewing kernel and boot messages. What it does: DMS prints the kernel ring buffer, early boot messages, driver messages, hardware errors. It is great for device or driver or hardware troubleshooting. Basic usage: show kernel ring buffer page with less sudo dmsk pipe less Human readable timestamps. Convert seconds in boot. Vault time. Sudo dmask hyphen capital T pi plus hyphen capital E converts timestamps to human format. Useful but can be approximate in some edge cases. Follow new kernel messages. Tail like sudo dmask hyphen follow or colon sudo dmask hyphen w useful when plugging in USB devices, loading modules, watching kernel messages as tests run. Filter by severity or error level. Show only serious messages. EM, ERG or crit or ERR or WAN. Sudo dmask hyphen level is equal to EM, ERG, emerge, alert, crit, ERR, WAN. Sudo dmask hyphen level is equal to ERR, WAN. This catches kernel errors or warnings without noise. Read and clear. Be careful. Dmask hyphen C. Print and clear the ring buffer. Root only. Dmask hyphen capital C. Clear the ring buffer. Clearing can hide diagnostic info and is used by attackers to cover tracks, so use only when you mean to. Set console log level. Control messages printed to console. Temporary kernel log. Console log level. Sudo dmask hyphen console hyphen level 3. Lower number is equal to show fewer messages on console. Combine with grep for quick hunts. Sudo dmask pipe grep hyphen I hyphen capital E single quote error. Pipe fail, pipe 1, pipe ATA, pipe I slash O error, pipe OOM, pipe panic, pipe call trace show, last endline sudo dmask pipe tail hyphen N 200. Look for I slash O error ATA USB OOM underscore reaper call trace kernel panic etc. Those keywords often point to hardware or driver problems. Use journalctl as an alternative kernel messages with timestamps across reboots. RHL uses journal to see kernel messages via the journal. Kernel messages from the journal. Sudo journalctl-k since in double quote to 2025-08-01 until 2025-08-08. Live follow of kernel messages. Sudo journalctl-k f journalctl-k is handy when you want consistent timestamps and multi-boot logs. Install systat. Sudo dnf install -y systat. Enable data collection. Sudo systemctl enable -now systat collect.timer systat-summary.timer. Immediate CPU live sample sar-u25. Historical CPU for today. Sudo sar-f/var/log/sa/sa $date plus %d-u. Per CPU sar-capital P all 1 3 block device input or output sar-d 1 space 1. Export to CSV. Sudo sadf-d /var/log/sa/sa $date plus %d-u. Redirect it to cpu.csv. Sudo show kernel buffer readable time. Sudo dmask-capital T pi plus. Follow kernel messages. Sudo dmask follow or sudo journalctl-k-f. Sudo kernel errors. Filter kernel error. Sudo dmask level is equal to emerg, alert, crit, err, WAN. RHL 9.5 boot flow. Short and graphical alt key terms. Power on. BIOS or UEFI post. Secure boot, firmware, NVRAM. UEFI boot manager or MBR EFI :shim x64.efi grub x64.efi or MBR BIOS stage. grub2 reads grub.cfg menu, loads VM Linux and initram fs kernel cmd line :root is equal to uid is equal to triple dot rgb quiet rd dot break. Kernel decompresses and early initram fs dragcut modules :disk, lvm, mdadm, crypt setup or lux mounts real root at or at slash sysroot may drop to initramfs shell. Switch underscore root or pivot underscore root system PID1 mounts slash proc slash sys slash save slash run sets C group V2 start system D hyphen udev D system D init start step read slash usr slash live slash system D slash system ampersand slash etc slash system D slash system default target SC Linux init mount slash etc slash fs tab entries start services network manager SSSD firewall D cron D rsyslog or journal D target reach multi-fn user dot target get at the rate gty1 text login graphical dot target gdm genome graphical login PAM authentication user session system D hyphen users timers late unit system fully operational post boot ops journal ctl-b system ctl-hyphen failed dmess quick terms and online checks BIOS or UEFI or NVRAM firmware boot order check EFI boot MGR-V MGR or GPT partition table types used by BIOS or UEFI SHIM x64.EFI or grub x64.EFI EFI binaries used when secure boot enabled grub2 bootloader config slash boot slash grub2 slash grub.cfg BIOS or slash boot slash EFI slash red hat slash grub.cfg UEFI commands grubby hyphen default hyphen kernel grub2 hyphen mk config hyphen o path VM linux or initramfs.img kernel and initial RAM file system in slash boot kernel cmd line root is equal to uuid is equal to triple dot rgb quiet rd dot break system d dot unit double is equal to rescue dot target edit via grub menu press C drag out initramfs assembles root lvm md adm luxor crypt setup tools els init rd slash boot slash initramfs hyphen ver dot img rebuild drag out hyphen f lvm or md adm or crypt setup lux volume management software raid disk encryption switch or underscore root a pivot slash underscore root handover from initramfs to real root system id system pid1 init system units in u slash usr slash live slash system d slash system and slash etc slash system d slash system key command system ctl status system ctl get hyphen default system ctl isolate target system d hyphen udev d device enumeration slash they populated here C group v2 resource control hierarchy used by system d slash proc slash sys slash save slash double asterisk virtual file systems mounted early SC Linux security policy enforcing or permissive config slash etc slash SC Linux slash config targets multi-fn user dot target graphical dot target rescue dot target emergency dot target gets backslash at the rate ty1 slash gdm double asterisk text console login versus graphical display manager PAM pluggable authentication modules for login system d hyphen user double asterisk per user system d instance logs and debug journal ctl hyphen b journal ctl hyphen k dmess system ctl hyphen failed rescue or debug options use rd.break initramfs system d.unit is equal to rescue dot target or emergency dot target kernel cmd line boot from rescue iso Solaris 11 boot process power on post BIOS or open boot PROM on Spark UEFI on x86 Spark OBP firmware runs self-test loads boot device from NVRAM variable boot device x86 BIOS or UEFI picks boot device boot disk MBR or EFI boot partition bootloader stage 1 Spark OBP executes boot BLK from boot device x86 BIOS loads boot 0, boot 1, boot 2. In Solaris 11, grub 2 is used on x86. Bootloader stage 2 Spark UFS boot reads slash platform slash dot 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 slash kernel slash UNIX signed slash platform slash dot 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 slash boot underscore archive. x86 grub 2 menu loads kernel UNIX plus boot archive kernel UNIX initialization decompress kernel initialize MMU CPU device tree Spark or ACPI. x86 mounts boot archive contains minimal root FS boot archive RAM disk contains slash etc slash system kernel modules SMF seed configs drivers loaded for root pool access ZFS drivers disk controllers mount root pool ZFS or pool import ZFS root pool or pool mount data sets for slash slash USR slash live slash var slash live etc. Switch underscore root to real root file system service management facility SMF bootstrap svc.start d becomes PAD1 instead of systemd in Linux. Read service manifest from slash live slash svc slash manifest and slash etc slash svc slash manifest. Starts milestone services in dependency order svc colon slash milestone slash single hyphen user svc colon slash milestone slash multi hyphen user svc colon slash milestone slash multi hyphen user hyphen server. Network services enable key services network or physical network or SSH system or logging system or file system or slash local network slash physical network slash SSH system slash logging system slash file system slash local SMF etc. Restarts failed services automatically if restartable login prompt text svc colon slash system slash console hyphen login graphical GDM or light DM via svc colon slash application slash graphical dot login PAM authentication user session SMF user services plus late daemons start system fully operational monitor by SMF and logs key Solaris 11 boot terms OBP open boot prom Spark firmware OK prompt for diagnostics variables like boot device auto boot boot BLK primary boot block reads UFS boot from disk UFS boot secondary bootloader for Spark grub 2 bootloader on x86 Solaris 11 config slash boot slash grub.cfg Unix Solaris kernel image boot archive RAM disk containing minimal OS to mount root pool updated with boot ADM update archive ZFS or pool root pool with data sets for system directories SMF service management facility Solaris init system commands svcs-ls services svc ADM enable or disable or restart control services svc-cfg modify service configs milestones SMF boot target similar to systemd targets in Linux single user multi user server none svc.startd master SMF daemon PID1 svc colon slash system slash console login text console login service PLAM pluggable authentication modules for authentication boot ADM manage boot archives and menu entries boot ADM list menu boot ADM update archive dmask or log ADM slash var slash ADM slash messages kernel and service logs reducing a logical volume in LVM reducing a large file system can cause data loss if not done carefully always back up first for ext4 or ext3 file system check current mount point and file system df-h capital T slash mount point unmount the file system replace lv underscore path umount slash dev slash vg name slash lv name run fsck to ensure file system is healthy to fsck-m slash dev slash vg name slash lv name string file system to a new size example 20g resize to fs slash dev slash vg name slash lv name 20g reduce lv size lv reduce capital L 20g slash dev slash vg name slash lv name remount mount slash dev slash vg name slash lv name slash mount point Verify df-h capital T slash mount point for XFS in LVM. XFS cannot be shrunk. The only way backup data, destroy LV, recreate smaller LV, restore data, backup your data, rsync -a capital X slash mount point slash backup slash location slash unmount the file system, u mount slash mount point, remove the LV remove slash save slash VG name slash LV name. Create a smaller LV create hyphen capital L 20G hyphen N LV name VG name. Create XFS file system mkfs.xfs slash save slash VG name slash LV name, mount it back, mount slash save slash VG name slash LV name on slash mount point, restore data rsync -a capital X slash backup slash location on slash mount point. Reducing size in ZFS. In ZFS, you cannot shrink a pool directly. Instead, you can reduce a dataset's quota to limit space usage or migrate data to a smaller pool. Reduce dataset quota. Check datasets and usage ZFS list. Set quota example 20G for pool name or dataset. ZFS set quota is equal to 20G pool name or dataset name. Verify ZFS get quota pool name or dataset name. Migrate to a smaller pool. If you need a smaller actual pool size, create a smaller pool. Send or receive data ZFS snapshot pool 1 or slash dataset at the rate snap 1. ZFS send pool 1 slash dataset at the rate snap 1 pipe ZFS receive pool 2 slash dataset. Destroy old pool if no longer needed. Summary table file system string possible method ext3 or ext4 in LVM. U mount E to FSCK resize to FS LV reduce. XFS in LVM backup recreate smaller LV restore. ZFS pool or quota pool no quota it is possible. ZFS set quota or migrate to new pool. When to use this? We have an XFS file system inside LVM or standalone. You cannot shrink XFS directly, so you must back up the file system with XFS dump. Destroy and recreate the smaller file system. Restore from backup. Step by step shrinking XFS with XFS dump. Check file system df-capital TH slash mount point. Make sure it says XFS. Backup with XFS dump. Create backup directory on another directory or NFS share mkdir slash backup. Dump the file system to a file. XFS dump capital G slash mount point pipe G zip. Redirect it to slash backup slash XFS underscore backup dot dump dot tz. Capital J enables extended attributes and ACLs dash dump to std out. Pipe gzip compress backup to save space slash mount point the file system you are backing up. Unmount and remove old LV. U mount slash mount point LV remove slash save slash VG name slash LV name. Create smaller LV and XFS file system. LV create capital L 20G N LV name VG name mkfs.xfs slash save slash VG name slash LV name. Mount the new file system. Mount slash save slash VG name slash LV name on slash mount point. Restore from backup G unzip C slash backup slash XFS underscore backup dot dump dot gz. Pipe XFS restore capital J slash mount point. G unzip C decompresses and sends to std out. XFS restore J capital J slash mount point restore from std into the new file system. Verify data ls-al slash mount point df-h capital T slash mount point. Important notes. XFS dump works only on mounted XFS file systems. Always store the dump on a different disk or pool than the one you are recreating. For very large file systems, you can dump directly to another mounted file system instead of creating a compressed file. XFS dump capital J slash mount point pipe XFS restore capital J slash mount point. This copies directly without making a separate dump file. In Solaris 11, DRS generally refers to Dynamic Reconfiguration Services, which is part of Solaris's Dynamic Reconfiguration DR framework. It's used mainly for hot plugging hardware, CPUs, memory, input or output boards, IO boards, NICs, HBAs without shutting down the OS. managing logical domains, LDOMs, or zones with resource adjustments on the fly, supporting enterprise Spark systems for capacity on demand operations. Key points about DRS in Solaris 11. Purpose enables online hardware changes while Solaris is running works with system firmware and service processors like ILOM, often used in high availability environments to avoid downtime. Core components TR and CFG commands are central. CFG configuration administration is used to attach or detach hardware resources. LDM command for Oracle VM server for Spark environments. Common commands check available disk dynamic reconfig slots. CFG-ADM-AL shows devices and their status connected, configured, unconfigured, unconfigure a CPU board. CFG-ADM-C unconfigure sys slot name. Configure a CPU board. CFG-ADM-C configure sys slot name. Removing a PCI card. CFG-ADM-C unconfigure AP underscore ID. DR in logical domains LDOMs. When running Solaris 11 in a Spark LDOM environment, you can dynamically add or remove vCPUs, memory, or in I/O devices to or from a domain. A command example LDM add-vCPU to my-domain, LDM rm-mem4g my-domain service daemon, dr-daemon dynamic reconfiguration daemon works with the service processor. It listens for hardware change requests from firmware or CFG ADM. Example workflow for DR. Let's say you want to remove a PCI HBA without downtime. Identify the device. CFG ADM-AL unconfigure it. CFG ADM-C unconfigure PCI 0 slot 3. Physically remove it if applicable. Confirm removal. CFG ADM-AL. Solaris 11 dynamic reconfiguration DRS or DR admin guide covering CPU, memory, PCI devices, and LDOM's resource changes with all important commands and examples. Solaris 11 dynamic reconfiguration DRS or DR guide. Overview dynamic reconfiguration DR in Solaris 11 lets you add, remove, or reallocate hardware resources while the system is running, avoiding downtime. It is used in enterprise Spark servers, capacity on demand, logical domains, LDOMs, or Oracle VM server for Spark, PCI hot plug, memory, or CPU hard add and removal. DRS is the service that enables and manages these reconfigurations. Check DR and DRS status. Bash SVCS DR SVCS DRD. DR dynamic reconfiguration service. DRD dynamic reconfiguration daemon listens for events. Start if not running. SVC ADM enable DR SVC ADM enable DRD. Key tools. CFG ADM administers attachment, configuration, and detachment of hardware. LDM manages Spark logical domains. PSR ADM enables or disables CPUs. PRT diag shows hardware diagnostic info. PRT conf display system configuration. DLADM network device admin for NIC DR. CPU dynamic reconfiguration list CPUs. PSR info-VP disable a CPU. PSR info-F online CPU underscore ID. Enable a CPU. PSR ADM-N online CPU underscore ID. PSR ADM-F offline 2. PSR ADM-N online 2. Memory dynamic reconfiguration. Check memory segment. CFG ADM-AL unconfigure memory. CFG ADM-C unconfigure sys board X. Configure memory. CFG ADM-C configure sys board X. PCI or input or output device dynamic reconfiguration list PCI slot. CFG ADM-AL example output AP underscore ID type receptacle occupant condition PCI 0 slot 3 PCI and PCI connected configured. OK. Remove PCI device. CFG ADM-C unconfigure PCI 0 slot 3. Add PCI device. CFG ADM-C configure PCI 0 slot 3 dynamic reconfiguration in LDOMs. Check domain resources. Bash LDM list. Add CPUs to domain. Add LDM add-vCPU to my-domain. Remove CPUs from a domain. LDM rm-vCPU 1 my-domain. Add memory to a domain. LDM add-mem4g my-domain. Remove memory from a domain. LDM rm-mem2g my-domain. Add a virtual NIC LTM add vnet1 primary vsw0 my domain. Example, removing a PC HPA without downtime. Identify device bash cfgadm-al. Find the device ID PCI 0 colon slot 3. Unconfiguring it. cfgadm-c unconfigure PCI 0 colon slot 3. Physically remove if applicable. Confirm removal. cfgadm-al notes and best practices. Always quiesce input or output before removing a device. Stop services using it. Remove some resources required. Domain reboot firmware doesn't support live DR. DR works best on Spark 10 M series servers with ILOM or ALOM. In LDOMs, changes are instant but might require guest OS to rescan hardware. Dev FS ADM.